This video is for Chemistry in the Earth System, Unit 2.4, Structure of the Periodic Table. Today's essential question is, how do scientists distinguish between metals, metalloids, and nonmetals? Our first main idea, the periodic table. The periodic table includes information about all the elements that have been discovered so far. Elements with similar chemical and physical properties are placed together within groups or families, which are the vertical columns. There are also patterns in the way elements appear within periods, or the horizontal rows. The period, or row number, indicates the number of electron energy levels in an atom of that element. But there are many versions of the periodic table, and they include slightly different information. The designations for the groups, for example, are presented in three main styles, with the European and US conventions using the letters A and B to label different parts of the periodic table. In the US model, the A groups include the main group elements, which are in columns 1, 2, and then 13 through 18. These are often called the representative elements. The B groups are the transition metals. The International Union of Pure and Applied Chemistry simply uses the numbers for groups 1 through 18. But in all versions of the periodic table, elements are placed in the periodic table according to increasing atomic number, or the number of protons in the atom's nucleus. The configuration of the electrons in an atom can be also predicted using the periodic table. Again, the configuration of electrons in an atom can also be predicted using the periodic table. These details about atomic structure affect the both chemical and physical properties of an element. Elements that appear in certain places on the periodic table exhibit certain similar characteristics. For example, elements can be classified as metals, nonmetals, or metalloids, depending on their properties. Next main idea, metals. Metals are located on the left-hand side of the periodic table. Metals are primarily in groups 1 through 12, although there are some metals in groups 13, 14, and 15, though very few. Metals exhibit similar properties to other metals. They have high melting points, and the melting point, remember, is the temperature at which a solid substance transforms into a liquid. Metals are usually solid at room temperature because of this property. Mercury, on the other hand, which is a highly toxic metal, is one of only two elements that exist in the liquid state at room temperature. Valence electrons are an important factor in determining the properties of an element. Valence electrons are those that atoms tend to gain, lose, or share during a chemical reaction. The group number corresponds with the number of valence electrons in the atoms of many elements. For the representative elements, which are indicated on the screen here, they are electrons in the outermost energy level. For example, elements in group 1 contain 1 valence electron. Elements in group 2 contain 2 valence electrons. For elements in groups 13 through 18, the number of valence electrons is 10 less than the group number. So an element in group 15, for example, has 5 valence electrons. Helium, however, is an exception to this rule. It is located in group 18, but it has 2 valence electrons. The elements in groups 3 through 12 do not follow this rule because the elements in group 3 through 12 have varying numbers of valence electrons. Valence electrons produce many of the familiar properties of metals. Most metals are quite reactive because they easily gain, lose, or share valence electrons. Metals are typically conductive, malleable, and ductile, and they also have shiny surfaces. A metal is a good conductor of heat and electricity. In solid metals, the valence electrons are shared equally among positive metal ions. These electrons that are shared flow freely between the nuclei of the metal atoms, such that they form a sea of electrons and move easily through the outer shells of metallic atoms, which explains why metals are good conductors. Now, the attraction between the positive metal ions and the sea of electrons is very strong. This explains why most metals have high melting points. Malleability, ductility, and luster are also physical properties exhibited by metals. Malleability being the ability of an element to be molded into another shape without breaking or cracking. Ductility is the ability of an atom or an element to be pulled into a long, thin wire. The sea of electrons can flow with metal ions when those metal ions move, and as a result, the metal ions slide past each other without breaking the bonds that hold them together. And lastly, luster refers to the shine reflected from an element's surface. Our next main idea, nonmetals. The non-metal elements are located on the upper right-hand side of the periodic table. Atoms of most nonmetals tend to gain valence electrons during chemical reactions. Again, atoms of most nonmetals tend to gain valence electrons during chemical reactions. The noble gases, however, are found on the far right-hand column. They are stable and tend not to react with other substances. Nonmetals as a group tend to have low melting points. This means that nonmetals are more likely to exist as gases when at room temperature. However, when they are solid, nonmetals often exhibit properties such as brittleness, poor conductivity, and dull surfaces. The term brittleness is used to describe how easily something crumbles or breaks. Glass, for example, is brittle and will often break if dropped. Steel, on the other hand, will not break if dropped. The properties of nonmetals are also explained by attractions between the valence electrons and the nuclei of those atoms. Unlike metals, nonmetals hold their valence electrons very tightly. Nonmetals tend to share electrons between other nonmetals to make molecules. Now, the molecules themselves do not share electrons with each other as the atoms do. Because of this reason, molecules are held together by weaker forces, which is why nonmetals tend to have low melting points and boiling points. Nonmetals are brittle because the electrons are not allowed to flow from one atom to another. Therefore, bonds break when the atoms move. Our last main idea, metalloids. There are only 7 elements that are considered metalloids. The metalloids appear in groups 13 through 16, where they form a jagged line in between the metals and nonmetals. The metalloids often exhibit properties of both metals and nonmetals. For example, metalloids are solid at room temperature and have luster just like metals. However, metalloids are usually brittle and behave like nonmetals. The physical properties of metalloids are related directly to the attractions between the valence electrons and their nuclei. Metalloids hold on to their electrons more tightly than do metals, but they hold them less tightly than do nonmetals. Metalloids tend to share electrons the way nonmetals do. Again, a sharing the way nonmetals do. The attraction between the electrons and their nuclei holds the electrons between atoms. And because these electrons cannot flow freely from atom to atom, metalloids tend to be brittle. Yet, under certain conditions, electrons can move between atoms, which is why a metalloid typically acts as a semiconductor. Semiconductors conduct heat and electricity more easily than a nonmetal, which is an insulator, but not as well as a metal, which is a conductor. Semiconductors are very important in the production of modern electronic devices. At this point, you should be able to generate a full and appropriate response to today's essential question. How do scientists distinguish between metals, metalloids, and nonmetals?